This is the second video for the summer videos. In this one, I'm going to do limits from a graph. So this is a large piecewise function here, and instead of doing it algebraically, we're just going to do it graphically. And this is usually the easiest type of limit to do. There's a bunch of pictures like this in your summer work packet. So if you ever get stuck, just refer back to this video again. What I'm doing on here is pretty much exactly what you're going to be doing in your packet. So first, let's do limits from the left, right, and then overall. Then we're going to talk about function values on it, and then we're going to talk about discontinuities, because there's a couple spots of discontinuity here that we want to just make sure we are aware of. In order to do an overall limit, like these guys here are the overall limits. I know that because there's no plus or minus after. You're going to have to do the limit from the left and from the right first, and then you can answer the overall one. So let's go to 2. So for the first one, I'm approaching 2. And that little minus, remember, that means from the left. So coming from the left means you're going to look what the graph is doing as you come from this way, from the left. Now, the graph isn't on the x-axis. The graph is right here. So it usually helps to put your pencil on it, follow it down, get closer and closer to x equals 2. Then you want to look, what are my y values doing? So like as I'm getting close to 2 on the x-axis, what are my y values doing? And in this case, notice the closer I get to 2, the closer my y value gets to -1. Now let's do the limit as I approach 2 from the right. So that means I'm looking at 2, I'm coming from this direction. Jump on your graph here, follow it, so get closer and closer to 2. Notice what your y values are doing. I'm getting closer and closer to this value, which just so happens to be 1. Uh-oh, my left limit and my right limit are not the same, so my overall limit cannot exist. The reason the limit doesn't exist is because I have a discontinuity here. This is a jump discontinuity. If there's a jump discontinuity at an x value, the limit can never exist. So it's impossible for it to. All right, now let's do at 3. So here's 3. Let's approach 3 from the left. So that means we're coming from this direction, jump on the graph. I'm getting closer and closer to 3. What are my y values doing? You might be thinking, well, there's not like a dot there or an open circle. There doesn't have to be. You're just going to see what y values am I approaching. In this case, not only am I approaching -1, but I also reach -1 because it's not like there's an open circle there or anything. Now let's approach 3 from the right. So I'm getting closer and closer to 3. Here I go. Ooh, what are my y values doing? Oh, same thing. They're approaching -1. Because the left and the right limits are the same, the overall limit exists. And I could have known that because the graph is continuous there. It's a smooth curve right there. No breaks or jumps. So my overall limit's -1. Okay, let's do -1 here. Limit from the left. So here's -1. I'm coming from the left. Jump on the function. I'm approaching -1. What are my y values doing? I'm approaching y equals 0. I don't actually reach it though because there's the hole. Approaching 1 from the right. So that means approaching -1. I'm sorry. So approaching -1 from the right. Get on the function. Getting closer, closer, closer. I'm approaching -1 and I reach -1. Oh, my left and right limits aren't the same, so my overall limit doesn't exist. And let's see why. Once again, look at that huge jump discontinuity right there. So jump discontinuity. So once again, the limit cannot exist there. Here, limit as x approaches 1. Well, notice I didn't ask for the left and right hand limits ahead of time, so that means you have to do them in your head quick. As I approach 1 from the left, my limit is 1. I don't approach it. I don't reach it, but I approach it. As I approach 1 from the right, my limit is 2, and I reach 2. But once again, I have a jump discontinuity there. The one-sided limits aren't the same, so the limit doesn't exist. Okay, these 3, well, these 2, I should say, are giving you an x value, because remember, it's O is f of x, and they're asking for the y value. You're just defining the function here. So f of 1, let's go to 1. And you might be thinking, well, some people say, oh, it's 1, and other people say that f of 1 is 2. Notice that right here, that's an open circle. That means the function doesn't actually reach that value. So f of 1 is actually 2. F of -1, some people would say it's 0. Some people say it's -1. Remember, here, it's an open circle. The function's not actually defined there. So at -1, my function's value is -1. Here, don't get confused, f of x is 1. I want to know what x is. Here, you are given the output, and you want to find out the input. Whoa, I misspelled that. Input. So the best way to do this is think, all right, my output, meaning my y value, is 1. So you want to scan your entire graph, go all the way across, and you want to find all the x values that have a y value of 1. All right, so right here, where's my pen? Here it is. Right here. So the first time that I reach a y value of 1 is right here. So you're going to go down to your x-axis and see where is that on the x-axis. So first spot is about negative 1.5. Moving along here, you might think, oh, look, I reach it here, but I don't actually reach a y value of 1. I approach it, but I never actually reach it. The y value here is 2 instead. So that doesn't count. Keep moving. Oh, right here I have a y value of 1. There's not a clear point there, but we can approximate it. That might be like 1.4. The next time I reach a y value of 1 is right here. That's at an x value of 2. Moving along, the next time I reach a y value of 1 is right here, and that is at 4. Now the 3 places where I have discontinuities were x equals negative 1, 1, and 2. So negative 1, 1, and 2. And actually the type, remember the types were right here. I have 3 main types. All of them were jump discontinuities. So all 3 are jump discontinuities. Okay, so I'm going to do one more. I'll do this one a lot quicker. In fact, what I'm going to do here is pause the video. I'm going to fill the answers in, and then I'll unpause it. So I would highly recommend getting a little sheet of paper or in the margin of a notebook, jotting down what the answers are, what you think they are, and then when I unpause it, you can check them quick. That's the best way to make sure you really know what you're doing here. So I'll pause it, I'll fill them in, and then there's like 4 I want to point out specifically. So go ahead and pause. So here are all the answers. Check to make sure that you got them all correct. The ones that are highlighted are the ones I want to point out quick. So let's start at negative 8 here. First of all, you should have seen that at negative 8, my limit from the left and my limit from the right are both negative 6. So that means the overall limit at negative 8 is negative 6. However, the function's value at negative 8 is not actually negative 6. It's redefined at negative 3 instead. So one thing that we're going to be emphasizing the first week of school is that this is the limit's value. So it's the limit as you approach negative 8. This is the function's value because it's f of negative 8. Since the limit's value and the function's value do not equal each other, that means it's not continuous. Not continuous. So anytime the limit's value doesn't equal the function's value, the function will not be continuous. And you can see it's not continuous because I have an open circle at negative 8. This is not a jump discontinuity though. This is the type right here. It's a point discontinuity because there's only a single point right there that makes it discontinuous. So there's a point discontinuity at x equals negative 8. This one here, so f of 2. Notice at 2, it's not like there's a clear dot here, but there doesn't have to be a clear dot like these things in order for a function to be defined there. At 2, my function's value was 3. And notice here that this is the limit's value as x approaches 2. This is the function's value at 2. Because they're equal to one another, that means it's continuous. So if the limit's value equals the function's value, it's continuous. If the limit's value does not equal the function's value, it's not continuous. Only other one I want to talk about is at negative 2, I have a one-sided limit as I approach 2 from the right. That would be coming from this way, so jump on that function. As I get closer and closer to x equaling 2, notice what happens to your function. Since it just goes up and there's nothing else going on, assume that there's a little arrow there and it keeps going up forever. I actually have an unbounded function right here. It keeps going up and up. So the y values are unbounded. So unbounded y values. That means that the y values are going towards infinity. In this case, they're going towards positive infinity. So the y values tend to infinity. In this case, on the right-hand side, I have an infinite discontinuity. Some people argue whether it's a jump or an infinite because on coming from the right or coming from the left, Some people say, oh, it looks like it's a jump, but then coming from the right, it looks infinite. It's kind of a hybrid of the two, but since the y values go towards infinity here, it's infinite discontinuity. All right, so hopefully you're all good on these. If you have any questions, just email me. The next 3 limit videos are the algebraically. So it's algebraically using direct substitution, dividing out. Then there's one-sided limits and conjugates. So check those out. And again, email me with any issues.